very knowledgeable about monitoring bees. We call her a scientist translator. And she is on our wall of honor, her picture's on the net. And basically, we nominated her partially because she could translate science to the rest of us. And so, take over and translate. All right.
Well, mostly it's about, I get to be the relatively bright novice who gets to ask all the dumb questions. So that is actually a pretty effective way of translating. Yeah, remember that. Recruit people to ask you the questions that nobody else will ask. Recruit people outside your field to ask you those questions. All right, this is always a treat. And we've got 4 more talks, and then we'll have our poster awards and our wrap-up, and then we'll all disperse out into the world again. So first up is Eric Anderson and Bob Steidel, presented by Eric Anderson. Eric has been out following little birdies around for several years now, and we get to hear some of the results. Very exciting.
Thanks, Edith. So, over the last few centuries, grasslands have not done particularly well. The global extent of grasslands has been reduced markedly through changes in anthropogenic land uses. And the grasslands that remain have really been subjected to a series of stressors that have really changed them in some big ways, including the facilitation of plant invasions. So, for the past few years, Bob Steidel and myself at the University of Arizona have been looking into how these plant invasions are affecting wildlife in grassland systems. At this event last year, I talked a little bit about one of the plant invasions that we've been looking at, invasions by non-native grasses. And this year, I want to talk about the other invasion, encroachment by woody plants. This is a phenomenon that's happening worldwide. It typically involves native species that were present in these systems historically, but in low densities. And over the last few centuries, have moved up. They've really increased in dominance, and in a lot of places they've really moved into upland grassland or savanna systems, transforming them into shrublands or woodlands in some instances. So we've got some great documentation of these changes in this area and elsewhere. This is a spot on the Santa Rita Experimental Range in 1902. So the Santa Rita Experimental Range is just on the other side of the Santa Rita Mountains. Grassland system pretty similar to Los Cienegos and some areas over here on this side, this north plain. So you can see kind of native grasses in the foreground. At this time, the mesquite, which is kind of the primary woody invader in this area, was restricted to kind of these more music bottomlands washes. Here's that same spot in 1941. You see mesquite starting to come out of that wash into the uplands. And here's the same spot in 2013. So by now you can see mesquite is really taking over the grassland system here. Black grounded grassland on the Jornada over in central New Mexico in 1933. Same spot in 2001, so big changes. And of course, it's not just restricted, this phenomenon is not restricted just to North America by any means. All over the world, this is a spot in Eastern Cape, South Africa in 1925, 1993, and 2011. So a lot of grassland savanna systems worldwide are actually changing into shrublands and woodlands. And not surprisingly, this is having a big effect on wildlife that are endemic to these grassland systems. Grassland birds, for example, have declined more than any other group of birds in North America over the last few decades. And although these declines are pretty well established, pretty well documented, the linkages between the plant invasions, these changes in structure and composition, and the link to grassland bird populations have not really been well established. So that's been the motivation for our work the last few years. Specifically, we're looking at how these plant invasions are affecting habitat selection, so changes in distribution of grassland birds, as well as how their numbers change, how abundance changes in the landscape, and also how well they do. So birds that are actually nesting, how productivity changes with invasions. And to kind of get at the mechanisms behind this, we're also looking at how some of the resources that the green birds depend on change. So I want to start off with just kind of a conceptual model that kind of lays out some of the things that we expect might be happening and some of the hypotheses that we've been looking at. So what we kind of expect to happen with woody plant encroachment is this transition from grasslands to shrub or savanna systems, and ultimately sometimes, depending on precipitation and soils and things like that, to woodland, to places where you get Woody cover up to around 30 or 40%, which is about what this region here can support in these upland grasslands. And often when you get to this point, you lose that herbaceous layer. And so as encroachment is occurring, what we kind of picture to happen with animals is this kind of changes in abundance. So some species, of course, do better. They're adapted to these grassland systems. They're going to decline. New species are going to come in that are adapted to shrublands or woodland systems. But of course, the distributions of these different animals and these species-specific abundance curves are not going to look like this. They're going to be much different. We don't really know the thresholds where certain animals come in, certain animals blink out. And so part of this is trying to figure out how different animals are affected and how and those points of cover where they are most affected. And so these changes in the abundance of different animals drives these community metrics, things like species richness. And so what we kind of expect is that initially, as woody plants move into a system, you get this increase in structural heterogeneity, kind of this your added structure to the grass-dominated systems. And new animals are able to exploit that typically. This increase in structure opens up a lot of niches, so we kind of expect more species to come in initially. What we're not so clear on is kind of what happens at these later stages of encroachment. So there's potentially a point where we may be losing some grassland obligate species, but we continue to gain more and more species that are associated with woodlands or shrublands. And so species composition could continue to increase. Another alternative is that if the number of losses of grassland obligate animals is about equal to what we gain, you might expect species richness to kind of peak out at a pretty similar level, or actually reach a pretty similar level to where it started. And of course, another possibility is that the losses of those grassland animals are going to exceed that of any gains, and then you get a real decrease in species richness. All right, so to get a better understanding of what actually is happening in our system, we wanted to sample a variety of grassland areas, of course constrained logistically. And so we wanted to identify some sites that really captured the range of structure in grasslands, arid grasslands of the Southwest, and a variety of management styles and practices. And so this is a historic extent of grasslands in our region, semi-arid grasslands, semi-desert grasslands, in the kind of more brownish colors. These are just a little bit more dry than the darker green, which are Great Plains grasslands, just a little bit music. And we identified 3 spots that we thought really captured this range of variation well in an area that we could actually work on. And if I zoom in on these, you're going to see this is, of course, an area that everybody here is very familiar with. And on these 3 sites, between 2013 and 2015, we sampled 140 10-hectare plots. We selected these plots at random along a gradient of woody plant encroachment. So we tried to get areas that were very much encroached and areas that were not. And we ended up with a pretty good sample. This is the distribution of woody plant cover on the plots that we sampled. So as you can see, we certainly had a little more effort in areas with less woody plants. And that's really an artifact of the fortunate fact that this area still contains a lot more areas that have not been heavily encroached. So it gets a little bit hard to find spots in the Sonoran Valley where woody plants exceed about 25%. And again, we're sampling strictly in upland grasslands that probably did not have a lot of mesquite in this historic times. All right, so on all these plots, we tried to find as many nests of grassland birds and any birds that we could. These guys are super secretive. Typically, the only way to find them is to flush adults that are incubating eggs or brooding chicks from the nest. And we do that by brushing the tips of the vegetation with the dowel as we walk around, or by dragging a really light chain that just kind of brushes the tips of the vegetation and flushes the birds. When we found nests, we would age them, either by looking at the development of the embryo or the chicks. And we would mark the nest in a way that would enable us to come back and find them every 3 or 4 days, but wouldn't attract predators to them. I also conducted point counts 4 times throughout the season at each one of these plots with just standard distance sampling protocol. And we measured vegetation a lot, lots of different scales. Plot scales and around nests. All right, so when it was all said and done, we detected about 5,600 birds, individuals of 83 species. And we monitored 177 nests of 27 species. And today I want to talk about some analyses where we looked at the effect of woody plant cover on species richness, occupancy of the 25 most common species, which make up about 89% of the total number of detections we had, and the density for the 10 most common species. And those 10 species made up about 72% of all the detections. So although we detected about 83 species out there, the vast majority of them were these 10 species. And finally, nest survival of 4 species that we have pretty good samples for, and that's about 73% of those nests. All right, so I'm going to show you a few different plots today. On all of these, the x-axis is going to be covered woody plants, and then the y is whatever response I'm talking about. So in this case, species richness. And what we found was that indeed species richness did increase as far as breeding birds in the early stages of encroachment, up to a peak probably right around 23–24%. As I mentioned, we didn't have as many plots that were heavily encroached, so these confidence intervals, which is this kind of shaded gray area, is a little bit wide for a lot of these, up above 30%. But basically, this kind of represents a point where these losses of grassland species begins to outweigh the gains in woodland and shrubland associated species. So that's where the peak seems to be in this system. All right, so occupancy is really just the probability of occurrence. So it's kind of tied in with the distribution of animals, whether or not an animal is likely to be using a particular area, and it counts for detection. All right, so what we found is that for a lot of species, occupancy really does increase with increasing cover of woody plants. So blue-gray speaks, mourning doves, black-throated sparrows, ash-throated flycatchers, ladderback woodpeckers, Lucy's warblers, brown-headed cowbirds, mockingbirds, cassin's kingbirds, and Buick's wrens all showed an increase in probability of occupancy with increasing cover of woody plants. And for quite a few species, we also found increases with woody plants but at peak kind of intermediate levels. So these guys are most likely to be in areas they kind of have these intermediate levels, so they might benefit from initial stages of encroachment. But as covered woody plant succeeds somewhere around these 15–25%, you start to see a decline. So these are species that can tolerate some woody plants and actually do better with some woody plants, but drop out of the system when those cover values increase much higher.
Can you just go back there and read the names and tell us the
Sure,
names?
yeah. So this is bullet oriole, canyon toady, curve-billed thrasher, Vermilion's flycatcher, and lark sparrow. All right, but not really a good picture for a lot of the species that we're more concerned with. So a lot of these birds that are tied to these grassland systems don't do as well. These 3, western kingbird, Scott's oriole, and cassin's sparrow, all actually benefited even just a little bit initially. So they actually, probability of occupancy increased a little bit, and then a little bit of shrubs in the landscape. And they do pretty well up until about 15–20%, and then you see this sharp decline. So these are species that do all right, with woody plant encroachment up to a certain limit. And then, of course, some of the ones we really think of as being obligate to grassland systems decline quite quickly with woody plant cover. So eastern meadowlark, grasshopper sparrows, and horned larks all show these pretty steep declines in probability of occupancy. If you've been counting, I told you there'd be 25 modern sparrow. It's kind of an interesting species. This is a bird that is a species of conservation concern for game, fish, and others. And it's one that's historically been classified as obligate to grasslands. But what we found was a bit of a surprise to me. They're just everywhere. We had them on basically every plot out there. So occupancy was basically 1 across the invading gradient for them. So occupancy tells you a bit of the story, but you can get a lot better. We can actually look at density. So we modeled density for several species, 10 species. And we did it in a way that enabled us to account for these variables that were really important to different species. So every model is kind of including covariates that were specifically engineered for that species. So first of all, density of all bird species combined, we saw an increase. So the more woody plants out there, the more birds get total. Not bad news. That pattern is really driven by a few of these species that increase quite steeply. Blue-gray speaks, black-throated sparrows, and Lucy's warbler all showed increases with increased cover of woody plants. And several species showed increases in probable peaks, kind of intermediate values. So again, this confidence intervals get a little bit wide, up around 30%. So we're not as sure that we really see those declines above that level, but certainly increases early on. So northern mockingbird, mourning dove, ash-throated flycatcher, and Bottom sparrow, grassland obligate bird that's actually most abundant when woody plants get around 20%. And again, kind of similar to what we found, occupancy, density of several of these birds that are really dependent on grasslands drop off quite abruptly. Eastern meadowlarks and cassin's sparrows to some degree. And grasshopper spirit is really one that's probably most affected by encroachment of woody plants. Once cover gets around 10%, these guys are gone. They're not around. And we also, when we start to look a little bit closer, a lot of these effects are kind of dependent on what type of woody plant we're looking at, be it a tree or shrub, for example. Cassis sparrow is one that, as I mentioned, declines with tree cover, total cover of woody plants. It actually increases with some shrub cover. So in early stages, these guys actually do better, or at least they're more than on the landscape. Just another example, northern mockingbirds. Kind of a peak tree cover around 20% or so. And these guys certainly are increasing with woody plant cover, but a decrease with shrubs. So this pattern is kind of indicative of this classic savanna structure, right? So you've got these big trees with very few shrubs underneath, and that's where the mockingbirds are most abundant. All right, so I'm going to move on to nest placement success here. We model success. Similarly, we were able to account for species-specific variables that were important. We looked at 4 species, grassland obligate, grasshopper sparrows, otter-eyed sparrows, those are sample sizes of nests there. A shrub specialist, black-throated sparrow, and then a generalist, a mourning dove. They'll nest in trees, they'll nest out in grassland with no shrubs around. They'll nest in your boots if you leave them out in the patio too long. So a couple things briefly on nest placement. Grasshopper sparrows and otter-eyed sparrows. This is the distance the nest was to the nearest shrub. So these guys are really avoiding places where shrubs are at. They're not putting the nest in kind of mediums really that have shrubs around. And then when we look at woody cover within a 10-meter radius of the nest, again, these guys are not putting the nest anywhere close to shrubs. So as shrubs increase in the landscape, places available to these territorial birds really decrease quite a bit.
So they nest right on the ground?
Yes.
Yes.
Yes. Yeah. And so even more extreme, within 1 meter of the nest, basically no woody plant cover for either one of those grasshopper obligates. All right, so keeping that in mind, the fact that grasshopper sparrows and otter-eyed sparrows really are not putting nests anywhere where cover is around, where there's any cover of woody plants around the 1 or 3 meter radius. Nevertheless, when we look at which of these scales where we could see some kind of effect on nesting cover, we didn't actually find a whole lot. I think I was a little bit surprised. We found effects for grasshopper sparrows at the 10 and 3 meter scales, black-throated sparrows at 1 meter, and mourning doves at the plot scale. And here's what those patterns look like for mourning doves: an increase with woody plant cover. And this is a pretty steep increase. These are daily survival rates, so you have to exponentiate them to the number of days to really see that effect. So it's a big response, and these guys do a lot better than nests are more likely to fledge chicks when there's more woody cover in the plot area. Black-throated sparrow showed actually a decrease. A little bit surprising. This is a shrub specialist. We expect them maybe to do better. I think what we're seeing here, I haven't really sussed it out yet. These guys either nest in mesquite or they nest in cholla. And so I think my guess is that the cholla nests just do better, and that's why you see this decline with woody plant cover. And finally, grasshopper sparrows. Note that the scales here, woody plant cover only up to about 6 or 7%. So like I mentioned, these guys really are not going to use areas where woody plants are much where cover values are much greater than that. For both of these, we did see a decline in success. All right, so briefly to wrap it up, with woody plants, abundance and species richness increased. So there's that. But that's really the cost of to these grassland obligates. So birds that are really endemic to these grassland systems that really depend on them, they don't do well. And they don't do well big time when it comes to woody plants. We're hoping that this work is identifying these specific thresholds where different species drop off, where different species enter the community, and hopefully this will help aid management in making decisions on restoration targets and conservation and whatnot. Of course, again, these grassland species really avoided nesting near shrubs or trees, and the effects, when they did, were not as pronounced as the effects on just density and occupancy. So I think the important thing there is that these guys are really just avoiding these areas. It's not that they're doing they're not doing poorly necessarily when they're using them, they're just not using them. They're avoiding areas. That's woody plants doing in the days. And so last year, I think I was trying to find a way to wrap up with a happy picture with non-native grasses, and that's hard because when non-native grasses come in, there's not a lot you can do. But with woody plants, it's kind of a different story. Restoration can be effective. BLM is doing some great work removing woody plants, and so it's not all a dire story here. We've actually got some hope for conservation and restoration. And thanks to everyone involved. I think I probably burned through all my time.
Time for one question.
What is it that allows the mesquites to spread where they should?
That's a big question. A lot of people have done a lot of work, and I think there might be some talks coming up on that. So there's certainly some large-scale things that are happening during this period. Climate change, changes in precipitation, nitrogen deposition. A lot of things are changing. There's pretty good evidence, I think more and more people might be agreeing, that a lot of local scale factors are involved. Typically these grasslands burned every 7 to 10 years out here. That stopped about 200 years ago through fire suppression, through reduction in fuel loads, through overgrazing, drought of course. And so I think it's certainly possible that, you know, prior to this time period when mesquites were not in these upland systems, they could have been there, but just as a seedling thing that would burn down every 7 to 10 years, grow up a little bit, burn down. So they were never dominant on the landscape. They might have always been there. Yes, great.
I had a question about wintering sparrows. Like I've also heard that we have an important habitat for that is, and I know Janet did some work, I think, in the early days. But what do you know, if anything, about that time period and the importance of
I think it deserves some study. I think, so a lot of the sparrows and other species that winter down here have been studied a little bit on breeding grounds, and they found aversions to woody plants on the breeding grounds, so I wouldn't be at all surprised if those same patterns hold true down here during the winter. I think the simple reality is that, you know, we're losing grasslands worldwide. You know, the species that do well are species that are common in lots of places. The ones that are disappearing are ones that are, you know, that benefit from not having those woody plants. So certainly putting effort towards getting rid of woody plants is probably good for a lot of animals.
And do we know the time period they nest well enough that like the vegetation treatment machines won't be out there during the nesting?
These guys are amazing. Like they'll actually, you know, the migratory ones like grasshopper sparrows and bottom-eye sparrows, they'll arrive in the breeding grounds really early, right around late April, early May. They'll set up territories, they'll defend those territories, but they don't nest at all until the monsoon rains.
So in the winter, you can do veg treatments in the winter and
Before or
not
after,
kill their
yeah.
babies.
Yeah.
Yeah.
All right.
Thanks.
Thanks.